All right, so first derivative was 1 minus cosine x. Now we're going on to step 4 where we're going to look at concave up, concave down by taking our second derivative. So the 1 is going to go to 0. Remember our DC negative. So if I differentiate a C trig function, it goes to negative. So cosine will go to negative sine. Now, I want you to just ask yourself, to draw this derivative number line, what do I set equal to 0? Can somebody maybe put that in the chat if I'm doing my concavity? So I'm about to do my concavity test here. What am I going to set equal to 0? I'm going to set the second derivative equal to 0. So I'm not going to worry about that first derivative. I'm done with the first derivative. I'm going to do everything with the second derivative, right? So it's all only with the second derivative. I'm going to set the second derivative equal to 0. Okay, so I have on my unit circle, my lovely unit circle, I am looking at where is the y coordinate equal to 0. Okay, so y coordinate just on that 0 to 2 pi interval is equal to 0 at 0. It's also equal to 0 at pi, right? So that coordinate would be negative 1 comma 0. And then it also is equal to 0 at 2 pi. So the solution to sine x equal to 0 is going to be x is equal to 0, pi, and 2 pi. Okay. So for our concavity test, and remember, this is not the second derivative test. This is a different situation. This is the concavity test or test for concavity. It is not the second derivative test. For the concavity test, I'm going to draw my number line, which is going to go from 0 to 2 pi. And then the only number I need to put down would be my pi. And I'm going to plug in to the second derivative. So my second derivative is sine x. So maybe from 0 to pi, I plug in pi over 2. So up here at pi over 2, I would be looking at a y coordinate of 1. So that would give me a positive. Now, I want you to ask yourself, what does that positive mean? Because I'm plugging into the second derivative and I'm using the concavity test, that second derivative is giving us different information, right? That second derivative is going to tell us that we're concave up on that first interval. And then from pi to 2 pi, maybe we plug in 3 pi over 2. So we have sine of 3 pi over 2. And again, that's down here at 3 pi over 2. You're looking at a coordinate of 0, comma, negative 1. So that will give you a negative. And that negative, because it's into the second derivative, is telling us that it's concave down. Right. Now, the last little piece of this puzzle is, do you have an inflection point? Okay, so the last part is, okay, yes, it's concave up on this interval, concave down on that interval, but then is there an inflection point? And to answer that, remember the first thing we have to do is say, okay, does this first derivative exist at pi? And the first derivative is defined for all numbers. It's just trig function, cosine's defined for all real numbers. So we're not concerned about does the first derivative exist. The first derivative does exist. And then our switch in concavity is happening at pi. So there is an inflection point at x is equal to pi because our first derivative exists. So we can talk about the second derivative, and there's a switch in concavity.